In machine learning, you hear two words thrown around a lot: generative and discriminative. They sound pretty similar, but they represent two completely different philosophies for how an AI can learn. Nailing this difference is, well, it's pretty important.
So let's make this simple. Imagine you have a big folder of pictures. Some are cats, some are dogs. Your job is to teach a computer to sort them. How would you start? What would you tell it to look for?
Turns out, your answer probably fits into one of two main camps. One way is super direct and focused. The other is a bit more, well, artistic. It tries to understand the whole picture.
By the end of this quick explainer, you're going to have a really clear mental model for both of these approaches. You'll get why it matters, and you'll know exactly when to pick one over the other.
Okay, let's start with the first philosophy. We'll call this one the pragmatist's approach. It's all about finding the most direct solution to our cat versus dog problem. The pragmatist doesn't really care about what makes a cat a cat. It just asks, what's the bare minimum I need to know to tell it apart from a dog? Maybe it's pointy ears versus floppy ears, or whiskers versus no whiskers. It's just looking for that one clear dividing line. This is what we call a discriminative model. See, it doesn't learn the essence of catness. It just learns how to discriminate between the two groups. It's a specialist that's really good at one thing: drawing that boundary. All right, now for the second philosophy. This one goes a whole lot deeper. This is the artist's approach. Now, the artist isn't happy with just a line. The artist wants to understand what makes a cat, and what makes a dog, a dog. It studies everything: the fur texture, the eye shape, the posture, to build this really rich, deep understanding. And this, of course, is the generative model. Because it learns the underlying data so well, it can do something that pragmatists just can't. It can generate a brand new, totally believable picture of a cat that has never existed before. It's not just a decider, it's a creator. So there's your core intuition right there. The pragmatist, our discriminative model, just draws a line. The artist, our generative model, learns the entire landscape. One separates, the other creates. Okay, so we've got the gut feeling for it. Now let's connect that to the actual language of probability. This will give us a much sharper definition. A discriminative model learns what's called the conditional probability, P of y given x. All that means is it asks a very direct question. Given this photo, what's the probability that the label is cat? It maps the input directly to an answer. A generative model, on the other hand, learns the joint probability P of x, y. This is a much bigger question. It asks, what's the probability of seeing this specific photo and the label cat together in the world? It models the data itself. Now here's the kicker. A generative model can still classify things, but it does it indirectly. It first learns that whole big picture, the joint probability. And then it uses a bit of math called Bayes' theorem to figure out the answer to the simple classification question. It kind of takes the scenic route, but it learns a lot more about the world on the way. So when should you be the pragmatist? And when should you be the artist? This is where we get into the practical side of things. Discriminative models are usually simpler and faster. Their focus is their superpower. They often get better results on pure classification because they aren't distracted by modeling extra details. Generative models are more complex because, well, they're learning more. This makes them great for things like filling in missing data, but it also means a weird outlier can sometimes throw off their whole picture of the world. You've definitely used both of these before. Your classic workhorses like logistic regression or support vector machines, they're discriminative. And all the models powering the huge generative AI boom like GANs and VAEs, well, the clue's in the name, they're generative. So, if your job is just to classify something, spam or not spam, cat or dog, a discriminative model is almost always your most efficient, direct tool for the job. But if you need to create something new, a picture, a paragraph of text, or even just more training data for another model, then you absolutely need the power of a generative model. All right, let's boil this all down to one final thought. A discriminative model learns the boundary. A generative model learns the data itself. It's the difference between drawing a line on a map and creating the entire map from scratch. So the next time you're starting a project, just ask yourself this one simple question. Is my goal to decide or is my goal to create?
the answer will point you straight to the right tool.